All right, now Unit 6, Day 2 notes. Let's go ahead and get started. Of course, these are your objectives. Now, first we're going to, again, we're only answering the starred problems. The rest of them you can try on your own. The key is going to be uploading Canvas. So for this particular one, let's start here. This is an equation. I usually put a line in between an equation so I know that whatever I do on this side, as in adding, subtracting, multiplying, whatever, not like here we're going to distribute. You're going to distribute on this side because it has a distributive property. But when we want to move things from side to side, that's when we're going to be doing it on both sides. So here is distributive property. We're multiplying 2 times x, that becomes 2x. 2 times negative 9 is negative 18. And then that negative 6 is just on the outside there. This is also the distributive property. Negative 2 times negative 5 is positive 10x. Negative 2 times 7 is negative 14. And then the negative 4x is out here on the side, on the outside. So let's go ahead and combine like terms on the sides first. We're going to combine 18 and negative 6. And again, don't be afraid to use your calculator. If you remember this from last video, this is Texas Instrument TI 30X2S. This is the only approved calculator for this course, and this is going to be approved all the way up to pre-calculus. So get one. It is very, very good investment. Go ahead and combine negative 18 and negative 6. So what I would do, I'd make it negative 18 minus 6. That will give you your answer. If you put negative 18 and negative 6, you're multiplying them. Minus in between them, but if the 18 is negative, you have to put that negative in the front. So I got negative 24, so it's going to be 2x minus 24 equals, I'm going to combine the 10x and the negative 4, that becomes 10 minus 4 is 6x, and then the negative 14. And just like I did last video, if you watched it, I'm going to always bring my x's on this side, okay? And then whatever numbers over here, I'm going to do the opposite. Negative, I'm making it positive 24, but if I do it on this side, I have to do that. The same thing on there. On this side, this is negative 14 plus 24, that becomes positive 10. And then 2x minus 6x is going to be what? Negative 4x. Okay? So although it looks like it should, in your mind, you're probably like, oh, that doesn't work because it doesn't become a perfect number. And these videos, they're not always going to be a perfect number, okay? Sometimes your answer will be a fraction or decimal, and we're going to make it a fraction. So if I divide by negative 4, because it's 4x, I'm dividing by negative 4 on both sides. I'll go ahead and put in my calculator. My answer, I want my answer to be a fraction. How do I get my answer to be a fraction if you remember from last class? Last notes. Day 1 notes, divide 10 by negative 4. I'm going to put 10, and instead of division, I'm going to push this A, B, B, C sign, and that is going to be the divided by negative 4. When you push this A, B, B, C, your answer is going to be a fraction when you get it out. Oh, what happened there? Oh, because I had the negative at the bottom. So if my fraction is like this, I can't have that negative at the bottom. So when I put it in my calculator, I'm going to put negative 10, and then I'm going to put the little backwards L, and then put 4. So 4 is now positive. So the whole fraction is negative. You don't have to have that negative at the bottom. It can go at the top as well, and it'll be the same basic answer. Okay. So in this particular, they don't like it when you put the negative at the bottom. So I'm going to, I want this to be right. Okay. Negative 10 divided, and I'm going to put this little A, B, B, C by 4, push enter, and my answer is negative 2 1/2. And if you want that as an improper fraction, I'm going to push that second button and then push the little A, B, B, C again. And it looks weird, but once you push the enter, it'll give you negative 5/2, and that is your answer as an improper fraction. Okay. All right, let's go down here. This one is pretty long, but we're going to get through it. Let's distribute property. Negative 3 times negative 9y is going to be positive 27y. Negative 3 times 8 is going to be negative 24. And then the negative 3y is just left there. Equals, let's go ahead and distribute it. 6 times y is 6y. 6 times negative 5 is negative 30. And then minus 9. So let's go ahead and combine like terms. We're combining like terms here. So 27y minus 3y is going to be 24y. We're bringing this down. It doesn't have anything that matches with it. Equals, and then we're going to combine these two. Negative 30 and negative 9. So this is 6y minus 39. Let's go ahead and bring this over here. Okay, and add the 24. And I do that every single time. I do the same thing every time so that I'm not confused. Okay, so with the 24 minus 24y minus 6y, I'm going to get 18y there. Okay, and then negative 39 plus 24. In that situation, I'm going to get negative 15. And again, they're not going to be pretty, but that's what I got. So in order to get y by itself, I have to divide by 18 on both sides. Move that to the side. And I'm going to throw this in my calculator and get my answer as a fraction. You can do it in your head or your calculator, negative 15. And again, I want my answer as a fraction. Divided by, I'm going to push the little a, b, b, c. It's right above the sign. And 18. And then push enter. My answer here is negative 5 over 6 as a fraction. If you wanted your answer to be a decimal, you just put it right in, negative 15, and you push the division sign by 18, and then it'll give you your answer as a fraction, okay? I mean, as a decimal. But we don't want a decimal, we wanted a fraction as an answer. Although it doesn't say for the most part, especially on Alex, they're going to want that answer as a fraction. All right, let's go to the other side. Okay, and remember to always follow the directions, follow the instructions below. Write x to the 5th with, x without exponents. Okay, so times x without exponents. So this is x to the 5th times x, and we're writing it without exponents. So what does that look like? Basically, we're going to write x 5 times, x times x times x times x. That's 1, 2, 3, 4, 5 times, and then that's x to the 5th. That's what we got for x to the 5th. We got this, and then times x. So they just want it written out. How many x's do we have here? 1, 2, 3, 4, 5, 6. It looks like we have 6 x's there. Okay. So now you can fill in the blank. When you have this and it equals this, what is that going to be once you add those together and put them in as an x with exponent? So at the top, you're writing with no exponent. Here, you're filling in the blank. How many x's do we have here? Once we wrote this all the way out, we had 5 plus the 1x. That becomes 6 there. Okay, so for that particular one, they wanted the exponent there, but they wanted to kind of show you visually what happens when you have x raised to the 5th power times just x to the 1 power. Okay, it became x to the 6. So in that case right here, this is going to be the same as what you're doing down here. But the x, the situation down here, and they want you to simplify, is that the bases are alike. They have to be alike if you're going to add these exponents. So that's why this is w and w and y and y and b and b and b and b. Okay, so if they're two different bases, you cannot add the exponents. So in this case, as I'm doing the one with the star, w cubed times w to the 4th, because they have the same base, I can add the exponents. So if I had to write this all the way out, I'd say w, that is w to the 3rd power, and this is w to the 4th power. And they're basically saying, how many w's do you have all together? 1, 2, 3, 4, 5, 6, 7. So this would be w to the 7th power. So the easier way to do this is when you have two numbers that have the same base and they're raised to a power, you just add those two. 3 plus 4 is 7. That's how we got that. Okay. So how are we going to do this one? When you see a b by itself, know that there's a 1 there. Okay. So all you're going to do is add the exponents there. So this becomes 2, 3, 4, 5, 6, 7, 8, 9. This is going to be b raised to the 9th power. So we don't have to write that out. All you're doing is adding exponents there. Okay? So I'm going to let you try those on your own. Let's move to the next section. Simplify your answer as much as possible. Here we're going to multiply because we're multiplying here. And then especially look at the x and this x here. You're going to add those exponents. So this will be 9 times -3, which will become -27. And this is x to the 1. Even though there's nothing there, it's going to be x to the 1. And this is x to the 8th power. Kind of wonky. Okay, you can barely see it. So basically all you're doing is adding those exponents. 8 plus 1 becomes x to the 9th. So that's how we got that answer there. Same situation here, and you're only adding it when the the bases are alike. So we're going to multiply all the numbers. 2 times 6 times 12. So 2 times 6 times, 3, not 12. This is 2, this is 6, this is 3. Hopefully you have printed out these notes so that you can see them very clearly on your paper. That all together became 36. The bases have to be alike for the exponents to add. So this is going to be u to the 9 plus 1, which is 10. I can only add the 2 that have the same base. And then the w is 4 plus 8. So this will be w to the 12th. I just added 4 and 8, I added those two, and then I added these two. Okay, so you can only add the ones that have the same base. So my answer here is 36 u to the 10th, w to the 12th. Let's try it here. All the numbers multiply by each other. So we're going to have 4 times 2 times 4. That becomes 32. And when there's nothing, remember that's 1. So with the y, I'm going to add the exponents y to the 4th. And then w, we're going to add the 7 and the 3, and we get w to the 7 plus 3 is 10. That's how we got that answer there. Okay, so that is that sheet. Let's move on to the next one. I'm going to go ahead and let you do that one on your own. Okay, because we already just did it. But I guess this is, no, we're going to do this one because I wanted to show you with the number in the front. So this one is saying without exponents, go ahead and write this out, 6x squared. So what you would do is write what? 6x times 6x. Because once you're squaring it, you're just writing it the same number again. So how would you answer that question? How would you multiply these two together? Again, like we did in the last page, multiply the two numbers. 6 times 6 is 36. That's why here in the first block, you put 36 there. And then, of course, with the exponents, when the bases are like, you add them. X and x becomes x squared. Okay, so that one would be actually squared. So your answer would look like this, 36x squared. That would be your answer there for when you filling in the blanks. So basically, you know, they're going to ask you to do the same thing. So when you're raising a power to a power, like they're doing here, they're raising a power to a power. What you're going to do there is actually multiply. Okay, so anytime you have an exponent raised to an exponent, you multiply those exponents. Okay, so in this particular situation, it's going to be y and then 2 times 5, which becomes y to the 10th. That's what you're going to do for those. And these exponent rules are a bear if you're not paying attention. Okay, you can really get tricked up on these. All right, so 5u raised to the 3rd power. What you're going to do there, again, 5u times 5u times 5u is what's going on there. Essentially, what you're doing is, and I'm going to put this little side note here, you're raising 5 to the 3rd power, and you're raising u to the 3rd power. So both of them get something, but both of them get raised to the 3rd power in this particular situation. So if I had to do 5 to the 3rd power, I just put it in my calculator. I'd raise 5 raised to, that's what the caret is, 5 raised to the 3rd power, push enter, trying to get the correct lighting here, and that becomes 125. So 125, and then u cubed. U plus U. 1 plus 1 plus 1 for this one is 3. So that's how I got that. All right, let's go down to this one. Again, everything gets that 5 raised to the 5th power. So we're going to have -2 raised to the 5th power. We're going to have b cubed. So basically with these two, what you would do if you had b cubed and you raise it to the 5th power, 5th power, you're going to be multiplying those two, because when you're raising a power to a power, you're multiplying. Remember, if you had 2 bases, side note over here, I always put these little, this is my thinking thought process. If I had 2 bases, base 5 and then base 3, I would add those two. So it'd be b to the 5 plus 3, which is 8. But if I had b to the 5th raised to the 3rd power, I would multiply those two. That's 15. So that's what's going to happen here. And then a squared has to be raised to the 5th power. So every single thing got raised to a power. So this becomes, I'm going to throw this in my calculator, -2 raised to the 5th power So sorry, I had to take a break. So now when I do that, my answer became -32. So here it is, -32. And again, you're multiplying these two. So this becomes b to the 15 because 3 times 5 is 15. And then a to the 10 because 2 times 5 is 10. So I did have to, when I was doing the number, I have to actually raise it to the power. For when I'm having a base with the number, you have to just multiply those two, okay? So this isn't very difficult, but it is something that you can get tricked up on if you're not paying attention to what's going on. So for this particular one, when you have the exponent on the outside of a fraction, you have this 3 has to go through every single thing individually. What do I mean? -5 has to be raised to the 3rd power. X to the 4th has to be raised to the 3rd power. And then this y at the bottom has to be raised to the 3rd power. That's just the page number, okay? So now if I put that in my calculator, I'm going to have -5 and raise that to the 3rd power. There. Again, -125. And then these two numbers, I'm going to multiply, x to the 12th over y cubed. That will be your answer there, okay? Now, the last one for this page, it'll be w squared raised to the 2nd power over, and then each of them separately, 9 squared, and then b, -9 squared, and then b to the 4th squared. Oh, I keep forgetting that. 4th squared. Okay, so every single one, every single number by itself got a squared. So with these two, you multiply w to the 4th. Okay, -9 times -9 is +81. And then these two you multiply, and that becomes b to the 8. And so because these have different bases, you can't do anything with those exponents there. Okay. Finally, last side. Okay, last side on day 2 for unit 6, day 2. For this particular one, again, same thing. We're going to give every single individual a exponent. So with this, I don't even have to show that work. All you're going to do is multiply because you're raising a power to a power. So this now becomes -x, okay, to the 6th power. Actually, let me write this out because this negative in the front makes it a little weird. So if I have this, remember that even though, although you don't see anything right there, that is a -1. Okay, and it actually has to have a squared as well. And that's where you're definitely going to be tricked. And then that x cubed has a squared, y cubed has a squared, and z cubed has a squared. And then this on the outside is just what? 3x squared y squared. It doesn't have anything on out here, so I'm just going to write it out. So now -1 squared is +1, and that's where you can get tricked up. Okay, that's +1. Here, multiply 3 times 2, that becomes x to the +6. This was y to the +6, and this is z to the +6 times 3x squared y squared. Okay, we're not done, because now the numbers 1 times 3, you can just multiply those. That just becomes 3. X to the 6, these have bases that are alike, so you add the exponents. And that's where up here we multiply. You add here because they both have 2 bases. Bases alike, you add. 6 plus 2 is 8. X to the 8th. Y, 6 plus 2 again is going to be y to the 8th. Z doesn't have any partner, so we're just going to leave it z to the 6th. This is your answer. This is not an easy concept. I think that it's not that it's difficult, it's just that there's so many rules when it comes to exponents, and we're not even done. We still have rules for subtracting down here with dividing. Okay? So with the actual number part of it, I'm going to put the numbers in my calculator. Okay? So with this particular, just the big numbers, we're going to put these in our calculator. 10 divided by 35, we want our answer to be a fraction. 10, and again, if we want our answer to be a fraction, we have to push the AB, divided by 35. Push that enter, you get 2/7. So in this particular case, this, when it simplifies, becomes 2/7. Now, the W here, when you have a 2 bases that are alike and you're dividing, you have to subtract the exponents. So this is a 1 and this is a 1. 1 minus 1 is 0. That's why these two cancel each other out. Okay, W up top, W at the bottom, X up top, X on the bottom, they're both 1. So it's basically 1 minus 1, that becomes 0. That's why you won't see those. Again, they go away. So let's try this here. 9 divided by 2, is there anything we can do with that? Let's try. Okay, 9, and then I want my answer as a fraction, divided by 2. Push enter, look, 4 1/2. But if I did second, because I don't want a mixed number, I wanted an actual improper fraction. Look at that, 9/2. It doesn't simplify. So since it doesn't simplify, I'm just going to leave it alone. 9/2. Oh, that's 27, guys. Oh my gosh, 9/27. Maybe it doesn't. It does simplify. What a mess. Okay, sorry. 9/27. There you go. 1/3. Sorry about that. All right. So 1/3. And let's see what everything else becomes. Well, the W doesn't have a W down here. Nothing's going on down here. I'm going to leave it where it is. X doesn't have an X down here. I'm going to leave it where it is. And look at the Y. The Y's cancel out. Okay? So if you have a 1 up top with other things, you're going to go ahead and place those other things up there. We're not even going to see the 1 over 3. Now, if 1 was by itself, it'd just be 1/3. But in this case, since the 1 wasn't by itself, we're going to just leave all the things that were up top instead of the 1 there. Okay? Now it gets down to the fun, because these have bases that are alike. Okay? And then you have the number up top, the number at the bottom. Basically, essentially what's happening is there's 4 X's up here. 1, 2, 3, 4, 2 X's down here. Okay? And as you know, they cancel each other out like that. So how many X's are you going to have? 2 X's up top becomes X squared. But then how you can also explain that is when you have the bases are alike, you're going to take the top number and subtract it from the bottom number. That becomes X squared. So these two things, you can do them either way. The bottom way is the way that you should do it. And the top way is basically explaining why that becomes that way. Okay? So let's go here. Again, we're going to do it the easier way. We're going to do it the way, the bottom way. We're going to take the top number and subtract it from the bottom number. So this is 7 minus 2. That becomes X to the 6th. That's how that becomes that. And that's only with the exponents, not the numbers. In this case, like with the numbers, we have to divide them like you regularly do. 49 divided by 35, and hopefully you'll get a lot of practice on this on Alex. And again, we do not want that mixed number. So since we don't want that mixed number, we're going to have to, sorry guys, 49 divided by 35. We are going to have that second X looking weird one and then push second and that. So then it'll be 7/5. Okay. So, or you can just do that in your head. 7/5. And again, with the top, it's going to be u to the 6 minus 4. Again, when they have the same base, you can subtract 6 minus 4. That's how we got up there. So your answer is going to be 7/5, yes, but the u is going to be 6 minus 4, which is u squared. U squared at the top. Okay. All right, let's do this one. 4 divided by 32. Push in, enter. I get 1/8. And look at this. This becomes y to the 1 minus 5. So you always take the top number minus the bottom number. Okay. So if you have that there, you have 1 is going to be y to the what? What is 1 minus 5? -4/8. If it has a negative exponent, and you're going to learn this later, but you might as well do it now, negative exponent, not a negative number, negative exponent, it has to switch. If it's at the bottom, it goes to the top, it goes to the bottom. So for this particular one, it's 1/8y to the 4th power, okay? Because that y, because it's y to the -4, has to come down, and when it comes down, it becomes positive. You will need to know this later. You might as well learn it now. There's no need to like shy away from it. So you might as well learn it now, okay? So 49 divided by 7, hopefully you know that's 7. And then it's going to be x to the 4th minus 1. Remember, the top number minus the bottom number. And that becomes 7, because 49 divided by 7 is 7. X to the 3rd power. That's going to be your answer there. And that is Unit 6, Day 2 note. Thank you.